That's funny.
Now, this is our little humor for today's class. Because yesterday you might not have any spouse, but today if you have a spouse, and then maybe tomorrow you have multiple spouses. That's what they like. So when can I start? Maybe I need to wait. Yeah. Because Tom said we can.
I finished my class a little bit late, so I think I'm trying to get food downstairs.
Yeah, so because I told her, because I also finished my class. So I just finished my class.
Yeah, I think you sent the email that the class will start at 1:10, so give them 5 minutes. I forgot that. I went out very fast because I finished my class and I was afraid the sushi would finish. So I ran fast to get the sushi good.
Yeah, that's why I didn't eat once.
You didn't eat anything?
Because I first my class at 12:50.
But I usually don't eat too much lunch, so I could have lived without it.
Not because one is just complaining about that. I need kids 90 minutes for my class every single time, so I try to spend.
That's okay, you can always make it up. Students get upset when you make the class longer. They don't get upset when you make the class short. Is that true?
That's true.
Or you can do it, it does. I like to see it first. You get much more peace. And so I can stay there. I brought something here that you guys might be interested. It's very pedestrian book on machine learning, but it's cheap, like $3. You want to have a look at this, how much for that? There was a big line in the cafeteria, coming all the way out of the cafeteria.
So do I need to wait?
Okay.
So this is an overview for today's class. So first 2 hours, I will cover 2 papers. One is a sexist paper, the other is a heteros paper. So basically they try to find out what is approach using the machine learning. And then after that, I will show one of my research is using the machine learning. So in this paper, they use a classification to find out what is a fraudulent company and then what is non-fraudulent company. However, in my research, I will show how to use the machine learning to find out optimal model. Do you know what is a machine learning? Okay. Have you ever heard machine learning before this class? Yeah, except so.
Training set from some.
Can you speak up?
You use
Yeah, I can hear you.
set, and you use a training set to find some.
So why do we need to use a training set? You mentioned that there is a training set in the machine learning.
You want to find some revelations. I think you want to use a training set to find some revelations, and then you can do the prediction.
So he mentioned that training set. Also, we wanna use the model, so we can develop the model using the training set, and then we can apply the model in the another data set, which is a test set. And then if we look at the Perro's paper, he defined the test set as an evaluation set. So in the machine learning, we want to develop the model. So before that, so I think I will show some idea for machine learning. Before that, if you look at the paper, you can find out first author, the Mark section, and then I invited him in the center. So if you want to see him in the not March 7, the April 7. So if you want to see him, you can look at his research during the seminar. So actually, he's a chair of accounting at University of South Carolina. So this is a definition of the machine learning. So if you look at the definition of the machine learning, you can find out machine learning is a subfield of the computer science. But now, everyone uses the machine learning, and then everyone mentioned that deep learning, machine learning, or something else. So if we look at the definition, it's not quite clear. However, if you know this picture, it might be easier. Sure. Because previously, so usually people learn from their experiences. However, if we use a smartphone or computer, there is an instruction. So even when you turn off your smartphone, and then if you turn on the smartphone, you don't need to do anything because there is already instruction from the developer. So now we want to use artificial intelligence. So there is a machine, and then machine learn from the data. So we have to provide instruction how to learn from the data from somewhere. So that is a machine learning. So I will show one video clip to find the machine learning.
And get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
Video, you might find out what is a machine learning. Then you find out what is the definition of the machine learning. So, machine learn something from the data. So, I will explain how to learn from the data, and then how to develop the data, and then what do we need to learn machine learning, because I think you are working on some empirical research. And then at that time, I just show the little humor. In that case, you might just want to draw the linear regression. However, in that case, you might have a broad interpretation from the data. So if you use a machine learning, you might have a better understanding with your data. So I will show how to use the machine learning. for empirical study as well as some classification. So this is some examples of the machine learning. So if you go to the Netflix, they recommend some movies. It is a part of the machine learning because they accumulate some data from the customers, and then finally they provide some information about the movie. So what is your preferred movies? So they recommend some movie based on the machine learning technique. Also, using a machine learning technique, pharmaceutical company provide personalized medicine. Also, if you look at the Dr. Alex Kogan's paper, he tried to find out the fraud using the machine learning. So we can find out credit card fraud using the machine learning. So why we need to use the machine learning, not human learning? Because human is not always rational. So machine is always rational, and then they can learn from the data. So people say machine learning, not human learning. So sometimes it happens to people because machine learning is consistent. However, human learning is not consistent always. So people say machine learning, not human learning. So if we look at this whole chart, this is the training test. And after that, your knowledge is exponentially increasing. So here is one example. So the vice president from the Netflix moved to this company, and then if you go to this website, this is a clothing company. However, you cannot find out any t-shirts, dress, or other clothes at all from this website. If you provide your data set, for example, your gender, your height, also your weight, they recommend the clothes for you because the company uses machine learning. So the company has a lot of inventory, and then they narrow down the inventory based using the machine learning. After that, the important part is still humans should use their judgment to determine what is an appropriate cause and then what is a good cause for everyone. So why do we need to learn machine learning? Because it's a hot topic. So if you look at the stock price for NVIDIA, if you watch the CES 2017, you find that this company, and then this company's presentation. And then if you look at the stock price for this company between 2016 and 2017, it is exponentially increased because they provide some application for machine learning. So everyone uses the machine learning in the world for stock to find out next stock price for tomorrow. Also, they try to find out, they try to predict anything else using the machine learning. Also, if you look at the stock price for AMD, you can find out it was exponentially increased from 2016 to 2017. So also, in the research perspective, you can find out Dr. Nichols' research using the machine learning. So this is Dr. Hussein Issa's paper. He used k-means for his research. Also, if you look at this is Tiffany, she was sister of Tiffany's right research, and then she used classification technique. One is a kind of the machine learning. She used decision tree. So if you look at the Perry's paper, he used a decision tree as well. Also, he used the example one of the Bayesian technique. And then after that, he mentioned that you issue use P-needs and fault finder to classify some ideas. So now in the accounting area, a lot of people use machine learning to develop their research. Also, if you look at the marketing community, this is the marketing science institute. Previously, in the marketing, they didn't use a machine learning at all. And then, if you apply the machine learning in the research, you might have the desk reject immediately. However, if you look at the research from last year, they started using the deep learning, one of the machine learning. So now, if you use a machine learning, it might be a good area for your research. He classified non-graduate company from graduate company. No, actually, graduate company from the non-graduate company. How does he classify graduate company from the non-graduate company? So he used a classification. So we want to separate graduate company and non-graduate company. How can you do that? Do you have any idea? Yes, Steven.
I guess you could use the information that's released after the fact. For example, if they audit the company and find out there was fraud, you would know there was a fraudulent company.
So, yeah, it's true. But, however, simply if you get this picture, and then you want to classify graduate company, if you visualize the data, and now you can provide graduate company's information here and non-graduate company information here. And then now, based on this graph, this figure, how to classify graduate company from the non-graduate company.
You could just draw a line.
It's true. So he mentioned that we just draw the one line. So now we want to draw the line. So he mentioned that in his in the Mark section's paper, he used SVM to draw this line. So now we have to know how to draw this line using the support vector machine in this class. So, do you know what is a logistic regression? So, I will compare SVM with logistic regression. So, basically, it is the same thing. However, because if we want to draw this line, we can use the SVM. And then if you are working on empirical research, you will use a logistic regression. For example, if you look at this equation is from Stiglitz paper. He used logistic regression rather than SVM. Because SVM and logistic regression, both of them using the binary information, binary dependent variable. So if we want to classify graduate company from the non-graduate company, we can use logistic regression or SVM. So when you draw the line, what do you have to do? What do you consider? So for example, when you working with the linear regression, what do you want to minimize?
Distance.
What?
Distance from the prediction and the actual value.
Yes. So he mentioned that if we want to draw the line between the data and then we want to provide a model based on the data, linear regression, we need to minimize procedure. So he measured the distance between the actual data and then the line, predicted line. So, there is a data, and then we want to develop a model. So we want to analyze this data using the linear regression. So in this case, you might want to draw this line. Then in this case, this is a predicted line. And then we want to minimize the distance between data and then actual value and predicted value. So theory is up. So this one is this predicted line is this line. And then we assume that this the actual data is B. So in that case, we want to minimize the distance, this value and this value. So we want to minimize minus. So, and then this one is same as. So basically, when you draw this line, we want to minimize the distance between actual data and the predicted value. So if we look at the logistic regression, we want to minimize the value, the difference between the actual data and predicted value. Actual value and predicted value. So we want to minimize the error term. So in other words, the difference between the actual value and data, the predicted value is the error. So we want to minimize the error. So in the logistic regression, it's the same as a linear regression. So we want to minimize the difference. However, if we look at the SVM, you can find the same term. So basically, logistic regression and SVM is same thing. So, however, you can find out another term here. So in the SVM, we want to minimize the objective function. The objective function includes this one, we don't know what it is at all. And then this one is the difference between the actual value and predicted value. So you might build that, no, I don't want to use this one, I want to use this one. Because it's much simple. So people usually use this one. Now, people don't want to use this one because if you find out there is another term, and then you can find out participation constraint. So people usually use this one when they are working on empirical research. However, if you use some SVM, you might have a better performance rather than logistic regression. So now we want to look at the SVM. This is the objective function. Objective function. So this is the error term, and then this is the sum value. So if we look at the physics paper, it defines this term as an empirical error. What is the difference between the actual value and predicted value? And then he mentioned that the first one is measure of complexity of classification. Do you know what it is? Okay, so I will explain that. So, however, you understand this one, right? The second time. So when you learn the regression, you need to minimize the procedure. So this is the same as a procedure. So you want to minimize this one, plus you also want to minimize this one. So now we want to draw this line. So we want to focus this part because we want to classify red dots from the green dots. So we want to focus on one part. So how can you classify green dots from the red dots? So we just draw the line between green dots and red dots. And then we draw the line. So now we classify present company from the non-present companies. Draw this line. And then you can find out the distance in the middle of. So you want to draw this line. And then after that, you have to find out what is the distance between. This is observation. So distance from this line to the observation. And then also you want to find out the distance from hyperplane to this observation. So basically, because basically SBM is a linear separation. So we cannot draw a circle or other lines, other path lines. We cannot use a quadratic line because SBM is linear classification. So we need to only use a line. So now we want to classify these two different data sets. So how can you do that? So we can draw the line. This line. So do you think what is the best line to classify this one from this one?
To minimize misclassification. To,
Okay.
to
So
divide it
he
to half.
mentioned that there is a no error. So when you classify two data, we want to minimize the error. So in this case, there is a no error. So after that, what do we have to do? Yes.
I guess it's to separate the two sets as far as possible.
Yes, it's important idea. So we want to separate. We need to provide the line, and then the distance between this line and this point, and the also we can find out distance between we want to go back to the SVM function. So because this term describes the error term. So as I mentioned that there is a no error. So we can remove the second term because there is no error. Also, this part describes the error. So because there is a no error in the classification in the previous picture, we can remove this part. So we have this function. So we want to minimize this part. So now we need to consider the distance between the line and observation. So there's a no error, and then we want to draw this line. So you can find out the distance between this line and this point. How can you tell? So you might learn how to calculate, compute the distance from the one line to one point. When you guys went to junior high school. So basically, so here is one point, and then you wanna compute the distance from this point to this line. How can you calculate this one? You might already learn the formula. Yes.
Draw the orthogonal line.
Yes, and what is the formulation to compute this distance?
To cross product is 0.
Yes. It's engineering answer. So you can find out with. So I mentioned that this one is x1 and y1. And then this line is defined as x plus y plus. So this is line, and then this is a point. And then now we can compute this distance. So you already learned that what is the answer? Yes. So you already learned this one. Junior high school or high school. So the distance is this one square and the coefficient of y should be square. You already know this one. And this one. So we have to pass this value to this function. So now we can calculate the distance from this line to this point. So we can compute the distance from this line and this point. So this line is defined as the state wx minus v. So same as this one, we don't express the part the vector. So we still use this one instead of x and y. In this function, use x1 and x2 plus c equals 0. And then this one is 1. So in this case, it is a vector expression. And then we can compute the distance from this line to this observation using this equation. And then you find that W is here. So if we maximize the distance from this line to observation, basically we can minimize this term. Because if we increase distance, W should be increased. So in the SVM, we want to increase our distance between resident company and non-resident company. So we want to find out the line to maximize the distance between one type of the data and the other type of the data. Do you have any questions? We try to find out the observation to maximize the distance between this observation and this observation. So from the red dot, from the green dot. And then we assume that we want to draw the line between the observations. So we want to draw the line in the middle of the observation to maximize the distance between this observation and another type of the observation. And then this is the distance between this line, between here and here. So the distance is defined this way. Do you have any questions? So we try to find out the maximum values between different type of the observation to classify the data. So as we mentioned that, as we discussed, we want to minimize this classification. So in this case, we can minimize this classification because there is no error. So that means we can minimize second term. However, if we consider the distance between blue and red one, we have to draw this line instead of this one. We want to maximize the margin between this data and this data. So if you are using the logistic regression, you might find this answer, this line. However, if you use an SVM, you can find out this line instead of this one. Because in the logistic regression, we want to minimize only second term. So we want to remove the misclassification between the two data in the logistic regression. However, if you use an SVM, even though there is an error, but we need to consider first term as well as a second term. So we want to find out the line to maximize the distance between two data sets, and also we want to minimize the misclassification. So do you have any questions? Yes?
This example, logistic regression is actually doing a better job than SVM, right?
Sometimes, because the problem is, if you look at the SVM, you can find out participation constraint. So there is a constraint. So this constraint should be satisfied. But however, if you look at the parent data, he mentioned in his data set, SVM outperformed than the others. If there is no, for example, if there is no misclassification, so if there is no error in this case, the performance of the SVM should be same as the performance of the logistic regression, right? If there is no, if we don't remove this data set, this data. minimize the second term, the misclassification, the error term. We try to find this one because we want to minimize the inequalities, which is the second term in the SVM. However, in the SVM, we need to find out maximum margin between two types of the observation. So we need to sum the confidence interval as well. So we can find out another minimization. However, if he mentioned that if there is a no error term, this value should be saved as a discovery. So this one is the first term, and then this one is a second term in the SVM. So if we use sum of two terms, we want to minimize the object inclusion here. However, in the logistic regression, we don't have this term. So we have a second error term. So we can find out, minimize the distribution here. However, if you look at SVM, we can minimize the object inclusion here. However, it was a very good question because in the SVM, we need to consider this participation constraint. It's not easy to satisfy. That because of this term, people using the logistic regression rather than SVM. So instead of the SVM, we can use Lasso. This is the absolute frequency and solution operator. It's the same thing. If you compare Lasso with the logistic regression, you can find out just the participation constraint. So in the logistic regression, this term. However, if we use a Lasso, we need to add up the constraint, which is the sum of the coefficient. So why do we need the participation constraint? And then, so it is a very simple one. So Lasso is always better than logistic regression. So which case do we need to use a Lasso rather than logistic regression? This is a coefficient. So it will be have the function. This one, and with that two execution and error. We want to minimize the sum of the beta 1 and beta 2. This is a constraint for the coefficient. So in that case, if we use a lasso, we can control the size of the coefficient.
Why will we get such a coefficient? Because in a logistic regression, the coefficients are supposed to be probabilities. How can you get a probability measure which is solar? It won't work.
So the probability means doesn't depend on variable, right?
Yeah.
So we have to look at the dependent variable and independent variable, and then you can find out the coefficient in the logistic regression. However, when you in the lasso, when we minimize the procedure between when we determine this coefficient, so basically when we determine the coefficient, we also need to consider the size of the coefficient. So basically, this answer might not be a good answer in the logistic regression because this size is really big. So I'll show another example. If we use a logistic regression, as the line should be this way. However, if we use a lasso, the line should be down this way. Because we can control the coefficient. Because in this case, one coefficient is exceptionally big. So in that case, we cannot, that means we didn't analyze the data correctly because of one outlier. So if we use a lasso, we can control this kind of outlier. So this data is wrong. So if you analyze the data in the United States, you can usually find out one exception from the Washington DC. Because there are, for example, if you find out, because there are a lot of factors in the Washington DC, relatively than the other states. So if you compare the healthcare, the welfare from the healthcare and number of factors, you might find out some exception from the Washington DC. So if you use a logistic regression, you might find out this one. However, if we control the coefficient, we find out this one. So we can find out like this.
So the effect of the lasso, it sounds like it can delete the extreme value of
Yeah, it can control, it cannot always delete the outlier, but it can potentially control some outlier. It's not always happen. So the other way to control this kind of outlier. Do you have any questions? So usually we can control outlier if we use a lasso rather than logistic regression. However, sometimes it does not work. So the best way to control outlier in this case, we can just visualize the data, and then we can easily find out what is the outlier. So people say, recently people say data visualization, because if we find out function, in this case, we cannot easily find out the outlier. However, if we visualize data, we can easily find out the outlier. And then we find that we can easily find out this function is a collective function in this data. So we don't need to analyze, we don't need to computerize something in this data to find out outlier. Just we need to visualize data, and then we can find out exception outlier. of circle here. And then we can classify red dot or green dot. This is a one way, and then we can use a quadratic function. However, as I mentioned, the SVM is linear classification. So we want to just draw the line to classify two data. In that case, we can use a circle. However, the better way, it's not better way, the other way to classification, we can just transfer, we can map this data to another space. And then, how can it map this data into another space? This way. We need to use a function. In this case, we cannot using the linear line. Can you, everyone can see this one? So if you draw one line here, you can find the one with classification. Instead of that, you can use this one, quadratic function. However, we want to use SVM, which is a linear classification. In this case, we can map this data to the different space. So we can create a function, and then after that, you can transfer this point, map this point in the other space. And you might find that it's slightly changed. So we can use function to map this data to this data. So we can just create a function, any function. And then after that, you might write down this line to classify this data from here, this data. So we need to know what is on this function. So if we look at the paper, imagine that validation kernel. Because we want to map this data into another space. Usually in the machine learning, it is called feature space. So we want to change the space using the one function. And then the function is defined is called kernel. So basically, in this case, if we use a linear line, we cannot classify. However, if we change the space, we can classify the data using the linear line. So in this case, we want to use the kernel. So first, we need to pre-process the data using the kernel, and then we need to transfer the data into another space. And then if we use an SVM, we can classify the data. So this, do you have any question? So this function is called as a kernel.
How do you know that such a function exists? How do you know that such a function exists?
Yeah, I will talk about it. So sometimes, in this case, this is a two-dimensional. And then using the kernel, we can transfer transfer the data, we can map this data to the 3D dimension. And then if you draw this hyperplane, this line in the 3D dimension, we can classify the data. So it is also possible. So but you thought that every function can be a model. It's not true. So we have to consider what kind of function can be a model. So you have to choose any function. And then to map this data into another picture space. However, you cannot use any function. So you have, when you consider, for example, if we use a normal distribution to transfer the data into another space, and then after that, you have to check the function satisfies this kind of condition. In that case, we can say the function is a model. So this is the function. And then we have to compute the function using the inner vector, inner product. And then you can compute this function using the inner product. And then after that, you have to check the characteristic of the product. Because these conditions that are satisfied, we can say that the function is a product. However, if we use the other types of the functions, such as causal function, you might learn that this one is not working. So in that case, we cannot use the function as a kernel. So in the second paper, you want to classify restaurant company from the non-restaurant company using the, so he found that he cannot separate a restaurant company from the non-restaurant company using the SPM. So he developed a kernel to separate the data using the SPM. So what he did is he considered year-over-year changes. So in the accounting, this variable is quite important in the financial statement. And also, this one is also important. And then, so if we have an account receivable and then current liability, we can describe the data. We can describe non-restaurant company and restaurant company using this value. For example, he mentioned that there's one company, and then we can describe this company using the sum value. 10, 11. And then there is another company, and the company's is only is so if we have only this value, we cannot separate this company from this company. However, if we use the one kernel, which is a year-over-year change using this kernel, we can separate this company from this company. financial column. And then, so if we look at the these values, using the these values, we can classify present company from the non-present company. So we need to consider, because this is a 60 method, so we cannot draw this one, and we cannot visualize this data. However, if we use this kernel, so these values, we can classify this company from this company. That's not, because it's a 60 method, so it's not quite clear. However, so we can draw this one visually. So basically, there are only one attribute, account receivable. So because year-over-year change is, we need to consider an attribute from the previous year. So we assume that this is an account receivable from the previous year, and then this is our account receivable for current year. In this case, we cannot classify present company from the non-present company. However, if we change the feature space using the year-over-year change, so this one is numerator is A1 and the denominator is A2. So we look at the year-over-year change in this case and this case. We find that, it can classify present company from the non-present company. So in this paper, the important part is he developed the mindset column. So using the SPM, we cannot classify present company from the non-present company. However, he changed the feature. He changed the feature space using the financial column. And then finally, he found that he can classify present company from the non-present company using the financial column. So now he developed the model. So his data is from the 1991 to 2003. And then in his example, is on 100%, 97% is a non-present company. And then 3% is a present company. If we look at the parent paper, it's on 0.3%, but he controls some ratio between two companies. He finds that it's on 3%. And then now, in the beginning of class, we define the machine learning. So we want to develop the model using the training set. But however, if there is a one data, we develop the model. And then after that, what do we have to do? We need to apply the model. Also, we need to validate the model. So in this case, if we have a one sample, we need to take two types of set. One is a training set, and the other is a test set. So he may call two sets of the data. One is a training set, and then the other is a training set. So he developed the model using the training set. And then if you look at the training set and test set, you can find out one characteristic because the ratio is not changed. So if you look at his paper, his training set is from 1991 to 2000. And then tested set in 2001 to 2003. Why he chose this year? Yes.
It is more close to the future characteristics. to predict 2004 or 2005.
Well, he can choose on 2003 and 2000 to 2003 instead of 2001 to 2003. Why he uses 2 years? So, for example, he can just choose a training set, just half and half. So, for example, 1991 to 1998, and then train test set is from the 1999 to 2003. But which is this kind of separation for training set and test set? Why he choose this year and this year?
To keep the same ratio.
Yes, because he does not want to characteristic of the data. So in this case, the important characteristic is what is that?
Ratio.
Yeah, between the present company and non-present company. So you can choose the data from the 2002, 2000 to 2003. However, you might find that the ratio might be different from the original data set. So here is our one data set. And this is the data set. And you can choose we can choose something. This is the training set. And this is the test set. For example, in his data, it is a you can choose this field. This is a training set, and then this is a test set. However, he chooses because we don't want to change the ratio. He does not want to change the ratio between the growth company and non-growth company from the original data set. Because in the original data set, 3% is growth company in the whole population. So when we test the data set, you have to make sure that you does not change the characteristic of the population. So sample set should reflect the characteristic of the population. So in this case, this is a whole data set. Then 3% is for the company. So training set, 3% is for the company. So in a test set, 3% is for the company. If he takes the years, he might be a 5%, and then he might be a 1%. In that case, we cannot validate our model because the ratio is changed. Do you have any question?
Can I just make a comment? I'm sorry to break in the wrong moment because I have to leave. What Professor Cho was showing me is very valuable because when I was studying engineering, I had to do linear programming simplex by hand. Okay, and some of these algorithms have been developed a long time ago, but they were not really usable because it was just too computationally complex. Now you have all these packages that you can use. You have R, you have etc. And you can extract vector machine, you can extract J51, you can do all kind of different machine learning technologies. And typically people will try the different models and see the one that they are going to use. The problem is that you need to understand what you're getting out. And very often you don't. So it's very important that you see what she's talking, understand what are the criteria that you choose your model. Because you are not going to compute this by hand, and you very often will not know how to do this. But because packages basically do this for you. But you will most likely will have to make selections on the basis of the data, the response that you get. Paul Burns did the dissertation, finished last year, and what he was doing, he created what we call the super app, which basically did the statistics on clustering, and then used statistical knowledge to choose out of the clustering what the results were. And I think that second part, which is the statistical knowledge, is the thing that you guys need to have. Okay, and remember, you're going to, at the end, have packages that do a lot of these machine learning things that you will use. But you're going to have to understand it. So it's more important even than knowing the mechanics is to understand what you get out. And that's why it's so interesting what she was explaining. I kind of enjoyed it myself. I learned a little bit.
That's only I will show how to use a webcam, because in the Perron's paper, he used just one software, and then he compared which one is a better application and then which one is not better application. So basically you can just use a software as he mentioned that. However, if you understand this one, for example, one coefficient should be the positive. However, if you analyze data and after that you find that it's a positive, and then when you explain why this coefficient is positive, if you understand this kind of mechanics, you can easily understand why the coefficient is positive rather than negative. So, in the section of the paper, the important part is one coefficient should be the positive. However, he finds that it's a negative correlation. So I'll talk about in the end of this presentation. So thank you for that. And I appreciate this comment. So you already know this song, right? So in the chemistry class, you already find out. He explained this one, right? It was just 2 weeks ago.
Can I just make a comment here too? I just can't keep my mouth shut here. I have to leave. Every time I talk with the company, they complain about getting too many false positives. Okay? And you have to explain that very basically. You have a population. The population is divided into positives and negatives. If you keep the same model and squeeze on the false positives, what you are doing is increasing your false negatives. Just kind of moving the thing. So there is a trade-off there. Now, what really matters at the end is the ratio in between positives and false positives, negatives and false negatives. And if you can reduce that, what you are making is a create more exact model. But just by changing your threshold, all what you are doing is increasing the false negatives. And it's so common when you talk with management, they always talk about false positives. Just the false positive is nothing. Because depending on, I think Professor Cho was explaining this, actually the ratios of the best approximation you can, the trade-offs that you are, is really what matter. And again, this comes out, you are going to use statistical packages to do the computation for you. The important thing is to understand what they are telling you, much more than how to do the package itself, because, and it would be nice to know how basically how they do it, because interpretation has something to do with it. Okay? Sorry about it.
Actually, Kevin explained this one. So what is a recall and what is a precision in his class, because this idea is quite important in text retrieval and then text analysis. So I think I believe that most of our PhD students already know what is a precision and what is a recall, because he spent 30 minutes to explain about that during his class.
So you see, that's a perfect table to explain this trade-off. I wish I had used this when I talk to managers complaining about false positives. We have just now starting a project with Banco do Brasil, very large bank in Brazil. And what they are doing is money laundering check. And they are complaining about too many positives, false positives. And by changing the threshold that they are choosing, it won't make any difference. Will continue being bad. What they need to do is improve the method that eliminates things that are, for example, in Arab countries, you know, you get a lot of Abu something, Abu Ben, Abu you, okay? Abu means father of. And we were doing that, and Abdullah was in our, finally he explained to us what it means. And so you get like 100,000 Abus, and you're trying to eliminate Abus. Not possible. That's not the way it works. Okay? So, at the end, to decrease the ratio of false to real, what you need to do is have the best pre-processing you can. Perros does a lot of pre-processing to improve that. But the other thing that Sue talked about, which is the accuracy of prediction, and the trade-offs of the cost of what you are doing, and the other things you mentioned was the balancing of your sample. You know, the number of fraudulent firms is very small that you detected compared with the population. So that's always a problem with this problem. And to make it even worse, you have, it's pretty clear, no one knows this, but it's pretty clear that among the negatives, there are a lot of positives, meaning how many firms had fraud detected. But there are fraud, there is much more real frauds that you haven't detected, or at least one particular account with material error. So anyway, keep an eye on this research, because this is going to be big in your entire careers. Sorry about this. No, not sorry, I have to say it.
Do you think what is a big problem between first negative and first positive? In the penalty paper, first negative is defined as a fraud company is classified on a fraud company. And then it could be how was the first positive. First positive means the fraud company is classified as a fraud company. So what is a big problem between first negative and first positive? Which one? Yes, first negative is a big problem. Because if we reclassify non-resident company to the resident company, there is no problem. Maybe we need to spend some money for this classification. However, if we classify fraud company as a non-fraud company, that's a big problem, because it can do harm to the stakeholders. So, parents assume that first negative is the positive for first negative is much higher than first positive. And then he So we need to sum up everything. And then accurate part is a true negative and true positive. So we need to look at the ratio between everything and true negative and true positive. So to calculate the accuracy, we need to use this one. And then in the chemistry class, I keep talking chemistry class. So in the common, what is a precision and what is a recall. So we develop the data, we develop the model using the training set. And then after that, we need to test the model using the test set. And then we can find out what is a true negative, true positive, false positive, and false negative from the test set. And then we can compute precision and recall. And then based on this compute, we can say our model is a good model and then our model is not a good model. So basically, when we measure the performance of our model, we have to consider precision and recall together. Then basically we need to find out what break point which is precision is equal to the recall. So we need to find out the break-even point, and then this area is worst performance because precision is very small and the recall is very small. So basically we cannot classify the data. And then in this case, precision is very high and the also recall is high. So we can say our model is better performance. Also, we can draw another line. So this is a receiver operating characteristic. So based on the information, first positive rate, the true positive rate, we can draw this line. So we develop a model using the training set, and then we find out true negative, first positive, and first negative, true positive from the test set. Basically, if you test the model, you already know what is a fraud company and then what is a non-fraud company. You already know all the information. Because you develop the model, and then you apply the model to the data set, and then you check it is really fraud company, and then it is not really fraud company. And then after that, you use the model for the continuous paper,
we have a limited data set,
cell size 2 samples, and then we can develop the model using the 8 samples. And then after that, we can validate the model using the 2 samples. And after that, we can develop the model again using the another 8 samples. And then we can test our sample using the 2 samples. So we can do same work to develop just one model. Because each sample reflects the whole population. So you develop a model from 8 samples, and then you can validate the model. So, and then after that, you develop the model again, and then you validate the model from the 2 samples. You can do this 5 times. So instead, this is the cross validation. Another types of the cross validation is, so if we look at the Kernel's paper, he used 10 words cross validation because he's a default setting in the website. So he didn't change any settings in the website, he just used a default setting to validate the model. Also, the other is a video on out validation. So we did just one observation to validate the model, and then we develop the model using the 2 samples. And then in the next step, we can develop a model using this sample and this sample, and then after that we can validate the model. So we want to develop one model, so we are keep doing the same work to develop the model. So however, if you develop that, if you want to have enough data to develop your algorithm for your model, what you have to do. So for example, if you look at the David Wang's paper, so you can see his paper. So because he did a seminar last year, and then if you look at his paper, even though it's in paper, you can find out only 50 seconds. But he published his paper to the very good journal because he did this work. So even though he has only 50 samples, he randomized his sample again and again, and then he boosted his sample set. And then after that, he analyzed the model. So if you don't have enough samples, enough number of your samples, you can just increase the sample size using the. So first you need to randomize your data set, and then you can just randomize, and then you can. For example, you have 2 samples, 3 samples. You can randomize this data, and then you can copy this data. Okay. So you can have enough number of samples. So first you have to randomize a data set, and then you can copy one data set here, and then after that you randomize this data set again, and then you can copy the data set again. So then just develop this model, even though there are some misclassification, but it will be considered a distance between the triangle and circle. We want to choose on this one. So you can find out the pieces that can be classified. So there is an overfitting problem. So if we look at this data, you can describe this data in this way. So for example, if you use a lot of variables, you might have this kind of result. So the problem is, if we look at the x-axis, we cannot predict less than 10. However, if we analyze data in this way, we can understand the trend of the data. So we can understand what is our next value for if there is a next value for x, we can predict the next value for y. So in this case, it is increased. However, in this case, x value is increased, y value is decreased. So it is not that way to understand the data set. So when you develop the data set, when you develop a model, you have to remove some features. So if we, for example, to this analyze data, if we use too many variables, you might find out this kind of curve, this kind of function. So sometimes you have to minimize the features to display your data set, and then you have to use the model. So for example, when you analyze, when you explain the data, what is the best way? Using just 5 features, 5 tables, or you can use 10 variables. What is the best way? If you use 10 variables, you might find out overfitting. Because, for example, you have 8 samples, and then you want to, if you use 10 variables, it's overfitting. Because anyway, you can draw the line for 8 samples. However, so that means you need to use just features less than the number of the variables when you analyze data. So in now here's paper, he classified the data using the first one is a neural network, and then SVM. And then I think that one is a decision tree, and then this is the logistic, and then tagging and stacking. So you ask during the break, so can you change the percentage of the non-resident company and resident company? The Harold's paper, and then he has classifiers with a different type of concept. And then he finds that SVM is the best one in the data set. But he considered the model, the percent between the resident company and non-resident company is imbalanced. So in the chemistry class, the best one is a 50-50. But in the real world, it's not 50-50, the ratio between the resident company and non-resident company. So he did test 5%, 10%, or 0.3% something, and then he tried to find out what is the best classifier between these classifiers. So basically what he did is he developed this function, this equation. So he already knows the given information is a percent of the broad company and percent of non-broad company. Because we already, if there is a data set, we already know the ratio. And then we can also know what is first negative and then positive, and then for to find out what is the best model using this model. Evaluation relative error cost. So he tried to find out what is the best model using this function. So how does he calculate this number? So he uses a software. So Professor Nichols mentioned that you can use software. So you don't have any idea about what is SDM, what is a decision tree, and then what is the features and all. You can use a software. So if you just search the webcam and Google, you can find out this software. And then if you click on this form, you can see. And then you can find out this browser. And then you can open a file. So basically in this software you can use a CSV file. So if you have an Excel file, you can transfer the file to the CSV file. And then you can open a file, and then you can choose the printer. So in the Peter's paper, he used normalize. Sometimes you don't need to use any function. So you can choose the one printer. So there are multiple printers. So you can choose a backward reduction or forward reduction, something else. So, and then after that, you can choose classifier. So SMO is, so in the Harold's paper, he used SMO. In the webcam, SMO is the same as an SVM. So if we use an SVM, and then after that, what he did is validate the model. He chose the cross-validation, 10 words, because this is a default setting in the webcam. And then he clicks start, and then finally he got this result. Based on this result, he computed this one, and then he compared the classification method. These are very simple. So if you look at this result, you can find out what is our precision, and what is our goal. Also, the Kevin mentioned that what is our best measure. So using this value, we can compare the classification method, SVM, logistic regression, and other things. Even though you can understand what is the model indication. So, since in the paper, the important part is this one. He found out the correlation because he looked at the year-over-year changes. Then he found out what is an indicator for the company. Okay, so for example, sales and preferred stock is a positive relationship between rate and growth. And now, how about this one? Third one. The ratio is total assets divided by the invest and expenses. He find that is not positive. Because in the product company, the value should be not negative. Because usually for the company try to liquidate their total assets. However, he find that it is not. So it should be not negative because the total assets should be not increased in the product company. Then, however, in his paper, he find it is not positive. So you might say his analysis is not correct. However, he mentioned that it might be another indicator for auditors because auditors always know that total asset to this ratio should be negative. But for the company already know what is an indicator to easily find out the product company. So in his model,
fraud company adding the non-existing asset to increase the total asset. In that case, we can positive relationship.
Yes. In the exceptional case, we say that is should be the outlier.
Okay.
So now our thinking is about research. It's not quite relevant with the accounting students, but I will just show how to find out optimal value using the machine learning. Because in the previous class, included there are two papers. They use the machine learning to classify non-profit company and profit company. However, I use a reinforcement learning. It can provide this kind of strategy to find out optimal value. So I will just show my research briefly. So because you guys are working on game theory problem during the break. So actually I'm working on game theory model. So to develop, to understand some technology impact or development in technology. Also, I'm working on some how humans accumulate knowledge change some people's decision. I'm working on two parts. So this is a game theoretical model. So I'm working on this one to understand different players' decision. So we can, so because in your model, so this is just one stage model. There is a no repeated model. In this case, I'm working on three stage model. So multiple stage model. So first, one player make a decision. So I assume that three players are involved in the model. So one player make a decision. And after that, another player make a decision based on the decision of the first stage. And then third stage, another player make a decision because she or he can observe the decision from the first stage and second stage. And based on the observation, the player make a decision. And then after that, to solve this problem, we need to use the algorithm regression. So you already learned this one, right? Some game perfectly equilibrium. So we have to find out equilibrium from here to the first stage. So I'm working on this one. So basically, I need to find out what is the best decision for each player. Now, I assume that there are three players, including consumer. So, important part for the consumer is the utility. So, you attended a presentation for Dr. Allen's presentation, right? He talked about AI semantics. And then he mentioned that he considered one individual's decision. Because in the economics model, we have to observe one individual's decision first, and then after that, we need to aggregate. So, aggregate the decisions to understand our society. So, I'm looking at one consumer's decision first, and then after that, I will go to the first stage and second stage, and then I develop this kind of model to explain our current situation. And then now I can work on, and then based on this model, I can explain what really happens in our real life. So basically, my model is what kind of carrier do you use? AT&T or T-Mobile, Verizon? So if you use a T-Mobile, you can find out you don't need to pay anything when you watch ESPN or YouTube because T-Mobile paid how money. So you don't need, it is not counted toward your data usage. So I'm working on that kind of model to explain why T-Mobile provides this kind of service. And then it was introduced in the video. So because it can explain why not use the model. This is our research. And then the other research is, as I mentioned, I'm using the machine learning. It's not really machine learning, but it's a kind of machine learning. And then how business maximizes profit if we can use a keyword auction. So you don't know what is a keyword auction in this sentence. So basically, if you search Google or Bing, you can find out this site, right side. And then we say this is a sponsored advertisement. So this result is based on the user search. So for Google, what is the most important part? So do you think how Google make a profit?
To advertise. No.
Yeah, advertising person.
The rank of the search result and the rank of the search result.
Search result.
Like which result should come first and which result should come later. And they also
They cannot change this one. So this sequence cannot be changed by Google. It is depending on the user. So, for example, one person search some keyword, and then next person search one keyword, and then he click the specific website. When the first person starts a keyword, and then he click very specific website, and after that another person arrives, and then he starts a keyword, and then he click the specific website, and then third one goes on next one, and then after that Google aggregate all of the data from the users, and then they place on which one is the top one and which one is the bottom one. So we cannot change this sequence, this order, because it is depending on the user's search result. So actually, the important asset for Google and Bing is a user. The important asset should be the users. So because if the user does not search anymore, Google cannot collect any data. So Google usually say the user is the most important asset for them. And then however, if we look at this part is an advertisement. So if a company wanna place their advertisement in the top side, they need to pay a lot of money to the Google. For example, if you search on one keyword, and then if you look at the right hand side, usually you can find out Amazon or other big companies because they spend a lot of money to place their advertisement on the top side. Because the companies doing that, if they place their advertisement in the first place or second place, usually user click the advertisement. So when you start something, did you look at the second page or third page? Sometimes we do not do that. So because we look at the first page and then we left the Google website because we do not do that. So advertisers try to place their advertisement on the first page and the top side. So my research is what is the basic strategy for advertiser to maximize their profit. So basically we want to place their advertisement in the first place. However, the problem is we have limited budget and a limited time for a small company. search engine open the function, and then advertisers bid or where to, if they wanna place their advertisement on the top side, they will bid with high price. And then if they wanna place their advertisement on the bottom side, they will not give you just $1 or $2. And then after that, consumer click advertisement, and then advertisers need to pay marketing price to the search engine. So basically, yes.
So the bid is only paid when the consumer clicks on the ad, not if.
So it is very interesting part. So if you bid, you don't need to pay anything. And then if you place advertisement, and then even though the advertisement appear to customer, you don't need to pay anything. The beautiful part is, if consumers click the advertisement, now the advertiser need to pay to the search engine. So if consumer does not click the advertisement, even though it is on the top side, advertiser does not need to pay anything to the search engine. So we try to find out what is the profit in the keyword search. So we can calculate what is the expected sales revenue, and then the revenue from the historical data, and then we can get advertising cost from the search engine. So it's not important part. So I didn't mention that this one. So basically, my research is based on this slide. So because usually, if you search on keyword, you do not get the second page. So most of advertisers wanna place their advertisement on the top side because more customers, they can attract more customers. So we wanna find out what is the best strategy because keyword search is for just a small company. So it is usually 2 or 3 cents for just one advertisement. So if you search the keyword, you can find out some advertisement. Yeah, for example, if you want to find out your dog, you can use this keyword advertisement. So if you just place your address, and then if you type in dog, you can find out someone trying to find out their dogs using the keyword because it is very cheap. So everyone can use this one, but it is specifically this keyword advertisement is for small companies. So because the cost is very cheap, so the problem is small company has two problems. We have a limited budget and then limited space. Because if you look at if you just imagine the theater, they have a very limited space. So for inventory, so they want to sell the inventory during the limited time. So we consider two things: budget constraint and then time constraint. And then we try to find out what is the optimal business strategy. So this is the budget and this is the time. So if they place their advertisement on the top side, they can attract more consumers. However, if they place their advertisement in a very low position, they cannot attract more customers, but they does not need to spend more money. Maybe they can attract more or 2 customers using the advertisement in the 10th place or 11th place. Because usually users try to click the advertisement to the top. So sometimes they can beat this amount, or
internet, right, people still paid money to advertise on things like billboards just to build brand awareness. So there's like an acknowledgement that there is like a benefit from that kind of expense. So if I was a company that had a limited budget or was running short on budget, wouldn't I have incentive to
That's the place, right?
Oh yeah, to try to
Always
bid
the case.
high on customers I know aren't going to click the link, because then they'll still at least associate my product with that. So is that something that's considered in this model, or?
Yes. So this part. The problem is they cannot make a sale in this case.
Oh, not immediately, but they're still getting profits.
Yeah. The
But not
advertisement
direct profits.
appear in the certain portal, certain Google, but they cannot make a sale. So usually consumers should click the advertisement, and then the consumers move to the website, and then finally they can make they can sell some product from the website.
I think the question is just slightly different. You are asking to overuse the Google's policies.
Yeah, so what I would do if I was a company is I would figure out the users that are like, I still want to target them, but I know that they're not going to actually click the link. And that way,
So you mean the advertisers that appear to the somewhere?
Yeah.
so the advertiser appears, but you never have to pay because no one clicks your link. And that way, every time, so if Nike comes up every time I search sneakers, even though I'm not clicking on the Nike link, I now associate Nike with sneakers.
The problem is, so if it is a brand, it might be useful. However, for just a small company, if the consumer does not click the advertisement, they cannot make a sale finally. So it's a problem. So
Eventually.
the problem is they can attract those two consumers during the whole year, and then consumers recognize the retailer because they can keep looking at the advertisement and search engine. However, they can sell only two products during the whole year. It's a big problem because usually small retailer has a very limited space, so they want to sell the product as soon as possible. Specifically, they consider seasonality. So I mentioned that there is a time constraint. So we tried. It's a complicated model, so I use stochastic.
How often they manipulate or change the bids to the bid?
Every second.
Everything. Oh,
And sometimes it's less than second.
oh yeah. But
So we consider the case. So audit is not regulated on the quality, and the other case, audit is regulated for time key. And then we develop the model. It's not important. So now the important part is this one. So basically, in the keyword of it's quite. So I'll show this one. So basically, good thing. So we try to find the optimal bid for advertisers. The problem is advertisers does not have initial information. So when they bid, they need to consider their competitors. So for example, I want to bid $5, and then my competitor does a bid $5.01. So finally, their advertisement is have a better position than me because it is a second position, and then finally because of the just 1 cent, I'll place my advertisement on the third place. So we don't have the information at all. Then based on the observation, based on the accumulated knowledge, we can change the weight, and then finally we can find the optimal strategy for to find the optimal weight in this case. So I usually invoice money. So in this case, so we determine one initial value, and then we keep changing the weight to find the optimal leading strategy. And then after that, we also get same thing. So if you look at this function and then previous function, parent is different. Finally, it is converted to the specific value. Also, it is totally different, but it is converted to this function. So because I developed the previous model, I showed the one stochastic model, and using the information, even though we don't have any initial value, we can keep the computer, we can keep change the bit, and then finally we can find out what is the optimal reading. So in this case, these are different. So this is our bit for advertisement, and then we can find out the optimal value. And then, so this is the bidding price, and then we keep finding out what is the best strategy during the advertising campaign. So it has a limited time and a limited budget. And then finally we find the optimal bidding price. So from here, in the end of the advertising campaign, we can find out what price for advertiser. And then we find that this one is the optimal bidding price. So if we look at the, we can draw the histogram, and then we find that this histogram, this conversion value is in the combination. So we find that one optimal bidding strategy, even though we don't have any initial information using the perspective. So basically, we use this strategy to find the optimal bidding strategy. So it is a kind of a machine learning. So we look at how people's knowledge is accumulated. So in a machine learning, so if you look at the gains with the AlphaGo, the machine keep learn something from the errors, and then finally it find out the machine find out the optimal strategy. So reinforcement, if you use the reinforcement learning, you cannot classify anything from the result. However, you can find out what is the optimal strategy for the company. So the problem is usually advertisers bid for multiple keywords. For example, Nike, you mentioned the Nike, and then Nike also use different keywords. So such as Nike or Nike sneakers, they bid, they participate in a bid for Nike and Nike sneakers, and then Nike shoes, something else. So we also verify our model. We try to develop our model for the multiple keyword, and then we find out the optimal strategy as well using the reinforcement learning. So this one is finally we can find the optimal strategy. However, we can find out some rules in this case. So this is a conclusion. So do you have any question? Please.
Can we use the K
Means?
K cross validation for the SVM?
Yes, we can use our K
So
cross validation.
in that case, do we have the case different model for using different the set to develop the model? I cannot.
First validation you wanna use the SVM, and then the second validation you wanna use the logistic regression or something else.
Not
We cannot do that. We have to use the same model. So we develop the model, and then to develop the model, we can use the we need to use the keyboard validation. So we have to use the same model.
So my question is two different case. We separate case, the subset for the case validation, and then first we developed the first subset to develop the SVM model by using first one and validating that model, and then moving to second set we developed the new another model for the SVM or no?
We have to use the same model.
Same
and then
model.
we keep trying to check our so in our first validation.
So just validation purposes.
Yes.
So it's without changing the initial parameter.
Initial
Models.
model. We don't change the model. So we use SVM for example, we have 5 samples, and we develop a model using these 4 samples, and then we validate the model. And after that, we use only these 4 samples to develop the model.
But by using different subset, it concluded the same different parameterized model, isn't it?
That's true. So usually people always ask their parameters. But same model still. Same
You mean
methodology.
same methodology, but different parameterized. So how can we converge into the final the
so
model?
usually keep all the same model. For example, if you look at the cost, if you look at the SVM, the cost is
yeah.
Actually, this knowledge, I did mention that WC, it can be changed anytime. So we can keep all the things value when you use a cross validation. So sometimes C can be moved to the inside in the integrator. So we can keep changing the C value, and then we can keep all the things in our model. Also, sometimes we can change the vector. Depending on your cost. Because, however, the problem is, some students ask for problem, we cannot predict, we cannot use a richer data set to predict the best one, best data set. So, for example, we cannot use a 2000, we cannot use data from 2001 to 2003 to predict the data from 1991 to 2000. So, that's in the paper, he didn't use a cross validation because usually we look at the panel data, so we cannot use the cross validation. However, if you look at the cross-sector data, you can use cross validation. So usually we keep all the testing the cost part. And then usually if you look at the full data set, you have to choose the very specific subset first. So if you look at the whole data set, the one sample is totally different from the other sample. Sometimes it happens. And then we develop the model using the different sample, different type of the sample, and after that we check our model using the other samples. Because it is very specific model, so it is sometimes we develop the model using a very specific different characteristic, it is usually applied to another part of the sample. So first you have to look at the whole sample, and then if you believe that a characteristic of the part is quite different from the others, you have to use the sample to develop the model, and then it might be applied to the other samples. So you have to choose the first one first. And do you have any question? Then basically, if we look at the sets in the paper, he uses sets for classification. So even though you cannot understand what really happens behind all the sets, you can use a set, or also for classification, you can find out, you can use a vector. So if you use SVM, so SVM can be an alternative way to find out the coefficient. So you can use a logistic regression to find out what is a coefficient in your model. However, you might believe that this coefficient is not collected. So for example, it should be a positive value, and then if you analyze the model, then you find that analyze the data, you find that it is a negative. In this case, if you use those SVM to analyze data, and if you find out the same result, your logistic regression should be correct. However, if you use an SVM, you find out different value, such as negative. So in that case, you might believe that your model is not correct. I think that's all for today's class. Do you have any questions?
What is the difference between logistic model and the probability?
Probability? I think someone can explain about that. So you have to develop a table, and then you have to look at it. It's quite complicated to explain now. So let's basically see it more focus on the probability. Also, you need to develop a table to explain the probability. So in this case, you can use a probability. Also, I cannot remember. There is something is a difference between the probability and the if I remember that, I will send the email to you. No, I forgot. There is a very important part. I couldn't remember that part because I took a qualifying exam, and there is a probability. There is a difference between the probability and the logistic model. So I remember at that time. Yeah.
Like the drivers